All right, these problems were very similar to the previous set of problems, except now we're dealing with perpendicular lines. So when you went to graph the perpendicular lines, you could have used any slopes that you wanted to use, but the relationship had to be that the two slopes are opposite sines and reciprocals of each other. So I chose my blue line there. I used the slope of 2 over 3, 2/3, positive, increasing. And then I go, okay, what's the opposite and reciprocal of 2/3? Opposite sign is going to be negative, and reciprocal is 3 over 2. And so then I graph that line there. I use the origin as my y-intercept, if you will, 0 for both of them. And then I graph that line. And what you should notice when you have perpendicular lines, if I actually connected all the discrete points there, we create 4 right angles would be created between those two lines. So perpendicular always creates 90-degree angle between the two lines. All right, let's write the equation of a line that's perpendicular to y equals 1/2 x plus 8 that goes to the point 1, negative 2. So again, very similar to what we just did with parallel, except for now we know that this equation, y equals 1/2 x plus 8, the slope is a half. But we want one that's perpendicular, so it's very important that we are making the right slope here. So our slope we're going to use is not 1/2. Reciprocal of 1 over 2 is 2 over 1, or just 2, and it's going to be a negative sign, right? Because that was positive, this has to be negative. So our slope's going to be just negative 2. I don't have to write 2 over 1. So let's do it. So we're going to go y minus, my y1 is the negative 2. So y minus negative 2, I'm going to say y plus 2 equals negative 2, that's my slope I'm using, the m, times x minus my x1 there, which is 1. So this would be x minus 1. Bam, we got it. All right, so now how do you graph this point? Well, this line, I should say. We have the point 1, negative 2. So I go right 1, down 2. Bam. The line goes through that point there. Okay, but there's a lot of lines that go through that point, right? If you only have one point, there's an infinite amount of lines that can go through one point. You always need at least 2 points to graph a line. So how do you get the next point? We're going to use the slope. So slope is negative 2. So I have 2 options. I could rise 2, go up 2, and then left 1. Up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1, all day, turn around a room. Or from that point, 1, negative 2, I could have went down 2, right 1, down 2, right 1, down 2, right 1, all day. Okay, the key is that the line should be decreasing because it has a negative slope. So always look at your line when you do this, just to make sure, kind of double check it yourself. Okay, should my line be decreasing? Yeah, it's a negative slope, right? If I had a positive slope, you catch your mistake. Oh, I went the wrong way. Okay. Okay, this time our slope of the line given is negative 2, but we want one that's perpendicular to that. So the slope we are going to use, well, negative 2 is negative 2 over 1. So the reciprocal is 1/2, and then I want it to be a positive because that was negative, so it's going to be positive 1/2 is our slope. All right, our x1 is the negative 2, our y1 is the negative 4. Substitute into our formula. We should be getting good at this now, right? Y minus negative 4, so I'm going to say y plus 4 equals my slope value, 1/2, multiplied by x minus negative 2, which becomes plus 2, right? Because we change it to add the opposite. We don't say minus and negative 2. We'll say plus 2 instead. All right, so now to graph it, we have the point negative 2, negative 4. So I go from the origin 0, 0, I go left 2, down 4. Boom. So the line goes to that point. Now we're going to use the slope to find other points on the line. So I can go, it's positive 1/2, so I go up 1, right 2, up 1, right 2, up 1, right 2, all day long. Or I go for that point, go down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2. Again, looking at your line, making sure it's a positive slope, so my line should be increasing. And it is. As x gets larger, y is getting larger. So that is an increasing line. It's going uphill. Our last problem for this topic is We're going to go ahead and rewrite the line that's perpendicular using the point slope form, and then we're going to convert it to our favorite form, slope intercept form. So the slope of the line given, y equals 3x plus 9, and slope is 3. So what's the perpendicular slope going to be? It's going to be m equals, reciprocal of 3 is 1 over 3, and it has to be opposite sign, so it's going to be negative 1/3. All right, our x1 is negative 2, our y1 is 5. Let's put it into the formula here. Ready? Y minus 5 equals negative 1/3 multiplied by x minus negative 2, so it's going to become plus 2. Perfect. All right, now we have to convert it to slope-intercept form. To do that, we do our friend the distributive property here. And so we're going to have y minus 5 equals negative 1/3 x minus 2/3. Oh, a little ugly for you, right? And then we're going to add 5 to both sides. Tell you what, since we're doing fractions, how can we convert that negative 5? How can we convert 5? We want to add 5 to thirds. Well, 5 times 3 is 15. So it's like I'm going to go plus 15/3 plus 15/3. Okay, so I get y equals negative 1/3 x plus 13/3. Sweet. It would have been acceptable if you want to change that to a mixed number. Some of you might have said y equals negative 1/3 x plus 4 1/3. Some of you may use your calculator and made it a decimal number, right? You might want y equals 1/3 x plus 4.33 or something like that. That would have been acceptable as well.